Let us see, deleting a box from our tree can be a little tricky. We use delete node function for that. First, we need to find the box we want to delete. Then we want to make sure that we don't mess up the connections in our tree. If the box we want to delete has no children, we can remove it. If it has one children, we can connect its parents to its child. If it has two children, we have to find a replacement for it. So there are total 3 conditions that comes here. The first condition is consider a tree. You want to delete this node. You can directly delete this. It won't be a big trouble. Consider you want to delete a node with one child. So we can delete this and connect these two. You have a tree like this. You want to delete this node. So what you will do is in the right side node, whichever the smallest element is there, this can be replaced here and solve the problem. So this will be removed by replacing this element to here, and you delete this element, will construct a new binary search tree. Let us see with an example. Consider you are having a tree with root is equal to null. That means this is a binary search tree with 0 nodes. If you observe here, there are 2 parameters that we are passing to the delete node. So the moment you call delete node, we are passing the root is null here, and consider you want to delete an element d. Here first it comes and checks with the condition root is null. The name that you want to delete is n. First it comes and checks with the condition root is equal to null. So root is equal to null, condition successful, and it straight away returns the null. That means we are not deleting anything. Let us see the second condition. We are having a tree something like this, and it has the value d, e, a, and this address is 100, and root is holding the value 100 here. So consider this address is 200. First, the moment you call delete node, so when you are calling the delete node, what happens? Root value that we are passing is 100. The element that you want to delete is e. So what happens when we call this one? First condition will be failed if root is equal to null. Root is not equal to null, root is equal to 100. E is nothing but the name. You need to understand the root which is here is different to the root which is there. You need to understand scope of variables. Next, first condition, if string compare name root name. So the name that you are looking for is e. E is lesser than d. Is the condition successful? No. This condition failed. Next, string compare name root greater than 0. So that means we are checking the condition if e is greater than d. Is the condition successful? Yes, the condition is successful. So it comes here. What it is doing? Root right is equal to delete node. That means it is calling the function. It's a recursive function. It is calling itself. Root right. Root right is what? So here in the box 200 address will be there. So 200 we are passing, and the name that you want to delete is e. So again this function will be called here. Here what we are checking? If root is equal to null, condition failed. Next, e is lesser than root name. So here root is what? Root is 200. So 200 name is what? E. E is lesser than e, condition failed. Next, if e is greater than e, again condition failed. Then obviously it comes to the else condition. When it comes to the else condition, what it is doing is, it means that e is equal to e. So it comes to the else part. Inside the else part, if root, what is the root value? Root value is 200, okay? 200 to the left is equal to null. So what it is checking? 200. So 200 left. So 200 left, it is null only. So is equal to null. It means it is creating a temporary variable that is a pointer that is pointing to the, here we are taking a temporary pointer that is pointing to the structure type. Here root is 200. What is 200 right? 200 right is also null. So we are temporary is equal to null. Then free root. So what is the root value here? 200. That means we are freeing or we are deleting this memory block that we created. And return temporary. So what is the temporary value? Null. To what it is returning? It is returning to root right. So what is the root right value? Here root is 100. 100 right value is 200. This will be replaced with null. That means we are having a new tree with the D and A elements. We have removed the node that is E. I hope this is clear. Let us see one more condition. Let us consider this binary search tree where we are having few elements or few nodes in it. Now, first for delete node I will mention here after dn. Okay. So in the delete node, root, what is the root value here? 100. And I want to delete the element B. So I am passing the value B inside it. What is the first condition? First condition, if root is equal to 100. Here this is the root and this is the name. The root which is here and the root which is here, these two are completely different. The root lifespan is inside this delete node. The root which is mentioned here is outside the delete node method. Here first condition is if root is equal to null. The condition failed because root is not equal to null. Next condition is if string compare name is B, B is less than D. The condition is successful. So we are going towards the left side. Root left is equal to delete node. What is the root left value? Root left value here 100. Root left is 200. We are passing the value 200 here and the value or the name that we want to delete is B. So this is the root, this is the name inside the delete node method. Inside the delete method, if root is equal to null, the condition is failed. Next condition is we are comparing B less than B. So root name, what is the root? 200. 200 name is B only. B less than B, condition failed. B greater than B, condition failed. Else it comes to the next part. So the element that we are deleting here. Let us see if root left. So what is the root value here? 200. 200 left is equal to null. The condition failed. Next condition, root right is equal to null. If 200 right is equal to null. So 200 right is null only. We don't have a right side child for the B. The condition is successful. So what we do, we create a temporary pointer that is pointing to the structure node that is equal to root left. What is the root value here? Root value is 200. 200 left. 200 left is 400. So towards the B, the left node that we are having is 400. Temporary is equal to 400. Then free root. What is the root value here? Again 200. That means we are deleting the B here. The memory that we created dynamically is deleted by using free. Next, return temporary. What is the temporary? 400. 400 is the node that is the child of B. Now return B. To where we are returning? Root left. What is the root value here? 100. 100 left. 100 left is already 200 is there. We are replacing it with 400. It means we are creating a connection between D and A. So this is the second time. So let us see the condition 3. In the condition 3, let us consider I want to delete G. If I want to delete G, what I will be doing is in the right subtree, smallest element is H. I will be replacing the H over there so that it will balance the tree. Consider that I have taken H here. When I take H, look at the E. E is smaller than H. Yes, condition successful. I is larger than H. Successful. J is larger than H. Successful. So the binary search tree property, all the right side elements are larger than the element that we are looking and left side elements are smaller than the element that we are looking. So let us root is equal to 100. So let us take this as 100, 200, 300. This is the address that I am randomly taking. 500, 600 and 700. Delete node. Delete node, the root value is 100. The name that I want to delete is G. So first we are calling if root is equal to null. So the condition failed. So root is equal to null, condition fail. Next, we check with the condition name G is lesser than root name. What is the root name here? Root is 100. Root is 100. Root name is D. G lesser than D. The condition failed. Next, G greater than D. Condition is successful. That means this helps us to go towards the right side. Inside that, what is there? Root right. What is the root here? 100. Root right is, what is the root right value? Root right value is 300. We are going towards the root right is equal to delete node root right name. Root right, what is the root right value? 200. That means we are passing the 200 value. Name here is G. We are calling again. It's a recursive function. Delete node. First condition failed. So the first condition is what? If root is equal to null. Root is not equal to null. Then next condition is root right. This is the root value. 200 is the root right value. And in this method, this becomes the root. G becomes name. G lesser than G. Condition failed. Next condition is G greater than G. The condition failed. So it comes back to the else part. When it comes to the else part, root left is equal to null. 300 left is null. The condition failed. 300 right is null. The condition is failed. So that means here both the conditions failed since it has 2 children. We are going to find the minimum value inside the right subtree. So the right subtree is IHJ. In this smallest value we are finding. We are using a temporary pointer that is equal to find minimum root right. So what is the root value here? 300. Root right is 500. So we are passing the 500 address to find minimum method. Current is equal to node. So node is a variable that holds the address 500. So current is equal to 500. You must be knowing how to find the smallest node in the binary search tree. Binary search tree smallest element if you want to find, you always need to go towards the left. Here this is the subtree. What we need to do? We just need to go to the left. The moment you go to the left, the last element that you are there in the left side is the smallest element. If you consider this whole tree, from D you just go to the left side. B, is there anything towards the left side of B? No. So B is the smallest element for this whole binary search tree. But if you are taking this subtree alone, H is the smallest element. The condition they have given here is while current and current left not equal to null. So current null. So for example, the current is now 500. 500 left is what? 700. Current left is equal to null? No. It has a value 700. So it enters inside. Current is equal to current left. Current value is 500. 500 left is what? 700. Now what we are doing? We updated the value current is equal to 700. Next, again it goes back to the while loop. Inside the while loop, it checks current and current left is equal to null. If you observe here, is current left is equal to null? 700 left is equal to null. So the condition failed. That means here both should not be equal to null. Here the moment it is equal to null, it comes out of the while loop, it returns current. What is the current value here? 700. 700 is written to what? Temporary. Now temporary is equal to 700. That means we need to copy the value 700 name value to 300 G value and delete this 700. That is the next step that we are going to do. If you observe string copy root name. So what is the root value here? Root value is 300 name 700 name. That means we are copying 700 name to 300 name. 700 name is what? H. We are copying H to 300 place. Similarly, what they are doing? Phone number. So 300 phone number to 700 phone number. Of course, we did not mention anything. If at all we have a number here, that will be copied over there. You observe, they are calling the delete node again. So root right is equal to, what we are doing is we are calling this function. So root right is equal to delete node. So delete node, root. What is the root value here? So the root value here is 300. 300 right is 500. So we are passing 500 comma temporary name. So the temporary address is 700. 700 name is what? H. We are calling delete node function again, where this function will be called and it will free this memory. And already we have copied H, the smallest in the right subtree, and replaced with the G that we want to delete. And it deletes this memory that we have created dynamically and copied it to the 300 position. This is the updated new tree by deleting the element G. So this is the third condition.